Hi, welcome to this lesson on probability counting principles part 1. Let's have a look at example 2. We're given the following word, assessment. Okay, so let's count how many letters are there. 3, 6, 9, 10. 10 letters. Of those 10 letters, they are made up of the following, of the 10 letters in that word, they're made up of the following letters. So there's one A, there's 1, 2, 3, 4 S's, there are 2 E's, there's 1 N, and 1 T. So let's do that maths there. 1 plus 4 is 5, 6, 7, 8, 9. So we're missing a letter, that is the letter M. So there's 1 M, that's 10. So those are the 10 letters. So if the repeated letters are considered different, how many ways can we arrange the letters of the word? So you can assume, again, any combination of the letters is a valid word. We're not really concerned that the words make sense in English language, but as long as you arrange them in a different way, it's a different word. Okay, so can you see that we're assuming that the repeated letters are considered different? So that means that, as we said, of that compromising letters there, okay, so there's 1 M here as well. So that's 1, 5, 7, 8, 9, 10. We assume each letter is different, unique. So there are essentially 10 factorial ways. Okay, 10 ways for the first letter times 9 letters, and for the second letter, 8 letters for the third letter, and so on, all the way up to 3, 2, 1. Okay, and if we do 10 factorial on our calculator, we should end up with that number. So let's check 10 factorial. Okay, and how do we read that number? That's 3,628,800 ways to arrange those letters. Now, if the repeated letters are considered identical, then how many ways can we arrange the letters? So if the repeated letters are considered identical, we are doing counting with identical objects. So we need to divide out those repetitions. So how do we do that? Well, there were 4 identical S's and 2 identical E's in the word assessment. Those were the only real repetitions. Every other letter was just put once. So by the fundamental counting principle, there are 10 factorial total ways of arranging all the letters, divided by the repetitions, the 4 factorial for the S's and the 2 factorials for the E's. So if we did this algebraically, what we can do is 10 factorial can be written as 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial, which is 4 times 3 times 2 times 1. And then 4 factorial we've got here, and 2 factorial we've got here. So the 4 factorials can divide into each other because everything is multiplication on the top and the bottom of the fraction. So you're left with this number here, 10 times 9 times 8 times 7 times 6 times 5, all divided by 2 times 1, which is 2. Okay, and then you can divide the 2 into any of the numbers. We could divide 2 into 6 and we could get 3. Or we could divide 2 into 8 and get 4. Okay, but you're just dividing out once. Okay, and then algebraically, if you put that in your calculator, you should get 75,600. But again, we can just straight up put that into a calculator. So we get 10 factorial divided by 4 factorial times 2 factorial. Okay, and then doing that, we get 75,600 ways. So can you see that number 75,600 is much smaller compared to the 3,628,800 ways we could have chosen in the first way. What was the difference? Well, in the first way, we considered all the letters to be unique. But in the second way that we counted, letters that were repeated were now considered identical. So whether you had the 2 E's next to each other that way in front of the word, or you had it somewhere else like this and you swap those 2 E's, it's still the same word. Okay, same thing with the S's. You could have had 2 S's here, 2 S's here, and then some letters in between them. And if you said you swapped these 2 S's and these 2 S's, that's still the same word. Okay, if those letters are considered identical. All right, so that is the second example for counting principles. I'll see you in the next one.